Welcome students, thanks for tuning in today. I'm Professor Klusman, to my left is Professor Obradovich and Professor Miller. Today the topic at hand, limits. What is a limit? Professor Obradovich, want to break it down for us today?
Yes, I can. Alright, as you can see right on the board, a limit is a value f of x that a function approaches as x approaches some value. So on your homework, you see it as written as a certain syntax. You'll see limit f of x as x approaches c. C is just an x value you see on the graph, equals the limit. So if you can see on the graph over here, you see an x value c. If you follow it up to the line, whatever the y value is, parallel to the point, is your limit. But just double check that on the graph to the left and right of the point comes to a point. Professor Miller, can you please show us an example of a limit?
For our first example, problem is find the limit of f of x as x approaches 0. So we need to look at our x-axis and see x approaches 0 on the graph right here. Okay, so we see there's a hole here, but when we look at our limits, the definition, as Professor Obradovich was saying, is that it's what the function approaches. It is put from the left and from the right. It is still approaching here. Just because there's a hole there does not mean the limit does not exist. So, as x approaches 0 right here, from the left and from the right, is at 2, so that would be our limit.
Alright, so here's our problem here. We gotta find limit f of x as x approaches negative 2. For this graph right here, you start down here and as x is approaching, we're going up and it does not reach negative 2 because that's where our asymptote's at. Then you do the same thing from this graph. As x approaches, it goes up towards infinity. We don't hit it because of negative 2. So if you look, both values here, it keep increasing, and they're never going to stop. So our value to this answer is infinity.
For our next example, we have the problem limit of x as x approaches 0 equals what? And from this graph, we can tell this is a 1 over x graph because there's an asymptote at x equals 0 because 1 over x is undefined. If we look at the lines that this graph makes, you can tell that as x approaches 0 from the upper half, it leads to infinity, and x approaches 0 from the bottom half, it leads to negative infinity. So because 1, we know that there's an asymptote x equals 0, and 2, the limit is approached from the left and right in different directions, we can tell that the limit does not exist.
Students, our next example, we have a limit f of x as x approaches pi. I'm looking at this graph and immediately I kind of notice this is like a base sine function. So with this graph, we can see it's continuous, no holes in it. But when you're looking at it, we want to find x is pi, where x is going to pi. So we're going through and we're trying to pinpoint it, but we can't pinpoint it because this graph continues all the way down. So if we really wanted to, we could draw this thing for eternity, but so we can't do that. So since we know that, since this goes off and on, analysis does not exist.
Next example, we have this function here, and the problem is find limit f of x as x approaches 2. So when we look at our problem here, this function is a piecewise graph. That's because it's not continuous, it's broken into 2 pieces here. So looking at our limit, zeroing on our point of 2, that'll be right here, going through here, we have to see where our graph approaches as we get to this line here. So, like in our definition, from the left side, the function approaches here. So that's 1, 2, 3, approaches 3 from the left side. So from the left, it approaches 3. Now we look from the right, come down at x equals 2, it approaches negative 1. So from the right is negative 1. So since from the left side and from the right side, they do not match up, that means the limit does not exist.